Hey, good morning, good afternoon, all new participants. We're waiting a couple more minutes for people to join. We're going to start in a minute. I see we're having many joiners, so just give them a minute or two to connect, and then we'll get going. All right, so we're 2 minutes past the hour, so I guess we'll get started. Hey everyone, welcome. We're going to be doing a webinar on things ChatGPT will not say about Kubernetes for production, things you should be aware of. You have two options to communicate with us. We have the chat, which is open. Feel free to chat away, ask some questions. We have some guys there helping us out with answering and general Q&A. If you want technical questions related to this, the content of this webinar, you're more than welcome to add a question in the Q&A section. I'll be getting to those at the end of this presentation, and hopefully everyone will be leaving this webinar with one or two things to take back home, to think about and to look into and make their production Kubernetes a bit better, a bit stronger. A bit about myself, for those of you who don't know me, I'm a DevOps architect at JFrog CTO office, been there for 7 years. Turned a developer turned into an infrastructure geek many years ago, and I keep doing it. I have a special place in my heart for Kubernetes. I've been working for Kubernetes for I'd say over 7 years, and taking JFrog into Kubernetes was one of my biggest and most interesting challenges. So everyone's using ChatGPT, I guess. Everyone's heard of it, everyone tried it out, whether for personal use or for business, for work. And it's been helpful for writing an essay, if you'd like, for some answers on technical questions or non-technical questions, if you want to write a nice cover letter for your CV, or you just want to try out and see where ChatGPT's limits are, like trying to troll it into thinking it's something it's not. So of course I did the same, and I started using ChatGPT on the week that it came out and became public. I was very curious to see how different its answers are from a normal web search. So I played around with it, and I started with some technical question, like asking it a basic question or asking it to write me something that I needed at that point. I must say not all answers were the most efficient one or were even right. So I was a bit disappointed on that aspect, but the nice thing is I could ask it to improve the solution, and many times it worked, many times it didn't. I asked it to look into an error that I found on my tests. That itself was very interesting and very challenging, because you need to remember that most of the information is based on things the OpenAI engine found on public internet. So many errors are mixed together, and many solutions are mixed together. It's hard to exactly find what you need and the one that matches your particular use case. I actually tried it for some personal advice, and in this case, it was actually very, very successful. Finding a good way to convince my 7-year-old why he should go and take a shower, and that was very, very useful and successful. So, of course, I found that it's the right time to ask it if it can give me some Kubernetes advice. So I asked him, give me the top best practices for Kubernetes in production. So it gave me a list, and every item in this list is correct and relevant. So I urge you, if you haven't done so, go ahead and try it out yourself and see what and how you can apply it on your environment. But I found that keeping Kubernetes at production grade, especially for us at JFrog, has much more than these 12 practices that it presented. I assume if I'd asked him for 50 practices, it will fill in the 50, but I'm not sure it will cover everything like we do. So just a slide about how we use Kubernetes in JFrog, just so you understand the context. We're running the whole JFrog platform on Kubernetes for over 6 years now. We're using the managed Kubernetes in the big 3 cloud providers, AWS, Azure, and GCP. We have more than 30 regions, and we have multiple Kubernetes clusters per region. Just for reference, we're using the managed databases, we're using the managed object storage in each one of the cloud providers. So the Kubernetes is used in our case for the workloads for the runtime rather than for storage. We have thousands of nodes overall. This number keeps changing because we have auto scaling enabled. Our clusters scale up, scale down as needed. And we have hundreds of thousands of pods, literally. I think the last time I looked, and again, that also varies. It comes up and up and down. Last time I looked, it was at about 300,000 pods running globally on our production. So that's a lot of pods and a lot of workloads to manage. We are releasing new application versions, patches, bug fixes on a near daily basis. We have a whole built-in system for rolling out new versions with proper canary testing before it's fully rolled out. And it works well for us for the past few years. So we learned many lessons while keeping our applications at 99.9% uptime on Kubernetes. And I'm going to share a few of them with you. And I think, and I hope, like I said in the beginning, I hope that everyone finds 1 or 2 items that are new to them or will let you take some homework back to your organization in the sense of how to make your production deployment a bit safer, a bit stronger, a bit faster, and a bit cheaper. So first of all, I was thinking of what should be the initial lesson I should share with you out of the lessons you're going to see in this presentation. I think sizing is one of the biggest ones that I wanted to share, because sizing is an art, and sizing is built from multiple types or multiple contexts of the sizing. So in this case, the node sizing. Smaller nodes for smaller blast radius, but too small will throttle your applications. So it's kind of a balancing act. Smaller nodes implies more nodes per cluster and more replicas of your daemon sets and other services, which might cost more. The overhead of the compute that needs to be run per node is eventually added up. Mixing of node types. In a Kubernetes cluster, you can have multiple node pools, and each node pool can be of a different node type. So you instance type. So you can go for CPU optimized for your CPU intensive workloads, and you can go for memory optimized for your memory intense workloads. And by finding the right combination, you optimize it for your purposes. And there isn't one correct answer here, But the key here is to understand that you can use this option, and it is even recommended to separate what's mission critical, what's not that critical, what's CPU intensive, what's not, disk intensive, and others. And you can use taints and tolerations for scheduling purposes. For a new deployment coming up, where should it put where should it put its pods in which node pool? And that also goes to the node itself, the CPU and memory ratio, something that we honestly sometimes tend to forget. Related to the kind of workload that you have and the kind of node, there is a very big difference with the core to memory ratio, which implies that you should adjust your resources on your containers to match that ratio as well. Because if I'll put an application, a container that has a 1:4 ratio, one CPU to 4 gigabytes of memory on its resource requests, on a node that has a 1:2 ratio, then theoretically, the most CPU I can allocate there will be half of the CPU. So you can do the math yourself and find out. We found, when we started out, we found that it has big impact on overall cost and efficiency of utilizing your nodes. You can very easily overlook this and find yourself using many more nodes for a lot less workloads. And of course, when you try to optimize or get to the best utilization of your node, you're trying to squeeze in as many pods as you can. That is a balancing act of itself, because every application, every service has a different behavior of how it consumes the CPU, the network IO, the disk IO. And we found that although nodes can host more than 100 pods at a time, we found that anywhere between 60 to 80 pods is our limit. And especially in cases where we have a single pod with many containers, because the actual runtime, end of the day, is the number of containers on your node. So find that sweet spot. What's the right balance for you? And then if you find that your balance is, let's say, 50 pods or even 100 pods per node, but the node is very big and you're underutilizing it, so maybe it's time to move to smaller nodes. And I guess save cost and get a much better optimization and utilization of your hardware. Balancing of the load, something that we've always been struggling with. It is an art of itself, because some of our services are CPU intensive and some are disk intensive and some are both. Most of the activities around Artifactory and Xray, for example, are periodic. So we'll have a customer that's running a very intensive build cycle that requires a very intense Xray scanning process. So during that time, we'll have high CPU and high disk usage. So we try and spread out the pods and the services between the different nodes, using either pod topology, spread constraints, or pod anti-affinity. You know your services, you know your application best. So try and spread out the load. There are different ways to do that. Spreading the load has been a very good lesson that we've learned fairly early on, when we started onboarding relatively big customers to our cloud services in Kubernetes. Disk limits. We tend to forget that the disks that are attached to our nodes have their own limits. And by default, the disks that are attached to our Kubernetes nodes are of medium size and performance. And if you have a very IOPS intensive service that requires a lot of disk access, you need to take that into consideration. We've run into many times when we've hit the disk capacity, whether it was the IOPS or the throughput. If you're familiar with the parameters, then the IOPS is the number of IO operations per second allowed per disk. And the throughput is how much throughput is allowed per second on a disk. So as an example, if I have a very high IOPS disk, 10,000 IOPS, but its throughput is limited to 250 megabytes, then I'm throttled at 250 megabytes, regardless of the IOPS I'm using. So again, this requires you to have good eyes on your monitoring, on your alerting, to see how your disks are behaving under pressure. And here again, it's a balancing act to find the right balance for you, to find the best utilization without compromising the availability and the performance of the service. Monitoring and alerting of these infrastructure layers is something that should be at very high priority, because if I have a node hosting 80 pods and the disk is throttled, then I have 80 pods, which comes to, I don't know, 160 containers or even more, all being throttled. Even if they're using minimal to no disk, they feel the effect of the throttling on the node itself. And this goes back to the node sizing that I talked to in the beginning of that blast radius. If you want a smaller blast radius, you want smaller nodes, but not too small, because then you'll throttle yourself up. The public cloud providers have very good monitoring on that, so you should be aware, familiar, and use it. Instead, in case you're using it, if not, instead you're using your own self-hosted, then I assume you have your own monitoring tools. Many times we saw cases where an application performance was degraded, and it took us a couple of minutes to understand the problem wasn't the application. It was because a noisy neighbor was consuming the disk on the underlying node, and that slowed that particular customer's service. Today, the cloud providers have more flexible options at playing with the parameters. In the past, you just needed to buy more and more size to get IOPS and throughput. But today, in the case of, for example, AWS EBS GP3 type, you're able to choose each parameter separately. So you're able to choose like a small disk, because I don't need a lot of storage, but I do need high performance with high IOPS and high throughput. It helped us very much when we needed that better control and better utilization of the resources. In many cases, we didn't need big disks, but we were holding very big disks just to enjoy the increased IOPS and throughput. But with the introduction of GP3, we could move to using much smaller disks and just increase the IOPS and throughput. By the way, that action alone saved us about 40% on our EBS costs for AWS, just by moving to much smaller disks, but increasing their individual IOPS and throughput parameters. The control plane, the Kubernetes control plane, and the Kubernetes services, the kubelet itself, are something that, especially in the managed services, is easy to overlook. You need to have an understanding of how they work and how hard they work. So today, there's, I think, a very good balance and a very good control over them by the cloud provider, but they all have their limits. First of all, they all expose monitoring, so be on top of it, monitoring and alerting, like before, because a slow control plane can impact the rest of the cluster's behavior, especially around handling of scheduling, upgrades, cluster scale ups and scale downs. And remember, even the managed services have their limits. We've had a catastrophe a few years back where we crashed a managed control plane because we were overusing its services and the cloud provider was not adjusting well. So we quickly fixed it, but it was something that we weren't prepared for. We didn't even give a thought to the fact that you're able to throttle up to crash the control plane that's not under your control. Protect your application's uptime. I hope you are familiar with these terms. but I'm going through them because these are some thoughts that are, again, overlooked many times, that we have to understand and prioritize our applications and services. Which of them have to be up at all costs and at all time, which are okay to fall once in a while and be restarted or rescheduled in the back. So we have a very clear understanding of what's high priority, what's less of a priority. And we play around with pod priorities and quality of service. If you're not familiar with these terms, go look them up. It helped us greatly in improving stability of our critical applications early on, years back. And we continue tuning them and optimizing them once in a while. Pod anti-affinity, if you have multiple replicas of the same service, it's sometimes very tempting to put them together on the same node because they're very fast talking to each other if they need to. But then you have a single point of failure. If something happens to that node, the node is hung or crashes or throttled, then both replicas of the service are hit. So we use pod anti-affinity. Like, for example, to make sure that two replicas of Artifactory for the same deployment will never be deployed on the same node. We force that. That's what we call a hard limit. Going back to the node pools, if you remember, I've mentioned it before, the idea of having dedicated node pools for mission critical applications. So for example, our ingress pods are mission critical. They're the gateway into our environments, into our platform. Without them, then it really doesn't matter who works and who doesn't. So we have a dedicated node pool for them and a few other services like Prometheus, because we have to have them at a much higher uptime. And with doing that, we dramatically improved, again, the stability of our services to our customers, because at the end of the day, that's what's most important. Plan to scale. It is something that you all have to have in your roadmap. Assuming everyone's roadmap is leading towards doubling of your deployments within a few years, then are you ready for it? What happens if tomorrow you are requested by your managers or by your customers, please give me double the workloads? Are you able to do that? Are you able to provide that capacity growth with no impact? Most deployments or most environments will not be ready to do that without some form of an adjustment. Cluster autoscaling, it is built into the managed services. Even there, understand what's the limits of your cluster size. I guess you've all seen a presentation in a KubeCon or whatever you've heard of telling you that someone's running a cluster with 5,000 nodes. We can't. We found that we're far from that because of the nature of our workloads, and that's okay. Because the nature of our workloads is such, we found that our capacity, for example, for a typical cluster in, I don't know, in GCP US West would be about 100 nodes. And if we reach that size, then we'll just spin up another cluster rather than trying to force that cluster to grow. And we're good with that. It is a comfortable and it's a comfortable sizing for us. We know how to manage it. We know how to horizontally scale the clusters themselves rather than the nodes within the cluster. And of course, take into consideration the application scaling. Are you familiar and are you comfortable with the scaling that your applications have today, both vertical and horizontal? These are things that you should try and challenge and ask yourself, what can be done in order to, again, better utilize the resources, not overconsume them, and find that right balance. As a rule of thumb, you'd always want to go towards a horizontal scaling where your workloads are simply replicated or duplicated, but then you have impact in the back that you need to be aware. You have more connections on the database, more connections on the storage. So that is also something that needs to be taken into consideration. Plan to fail. Your applications will fail. Your pods will fail. Your nodes will fail, and your cluster will fail. You should have a playbook for each one of these scenarios. What happens if my application fails? Oh, that's okay. My application knows how to recover. Since I have my application pods running in high availability, if one of them fails, I'm okay. I'm covered by the other. Are you okay with that? Are you not? What should you do? What happens if a node fails? Then again, since I have pod anti-affinity and all my applications are deployed with multiple replicas, then if a node fails, then I'm covered by other nodes, and the cloud provider will spin up an alternate node for me in that case, and I'll be rescheduled. What happens if my cluster fails? Like I've mentioned before, our control plane that can fail itself. So this plan to fail is something that should always be in the back of your head. You can never be over-prepared for this because something will fail. Have a cluster failure disaster recovery plan. It has to have a detailed plan, a detailed playbook, and you should practice it periodically. Our disaster recovery plan is rather complex, but it is based on the fact that we're replicating the database, we're replicating the storage to what we call a disaster recovery region. It is usually a geographically adjacent region. And in case my cluster or region fails, I know how to reprovision all of the environments in the DR, in the disaster recovery region, with a kind of a standby environment that we have there. And we are practicing it once in a while. We continuously learn and improve it. We still have gaps that we're working on completing, but we have a very clear playbook for each one of these scenarios, what to do in that case. Some of the work is still manual. Most of the work is automatic or semi-automatic. Eventually, we're looking at a full automatic solution there. What happens when you recover? There is great load when you try to recover many deployments that failed. Like in a disaster recovery scenario where your cluster is crashing, you're trying to start up the same workloads in another cluster, whether it's another cluster in the same region, whether it's your DR region. So you have to have very good control on a gradual deployment. You don't deploy 3,000 customers at once or 3,000 deployments at once, because they all consume resources from their nodes and from their database and from the control plane. And that amount of pressure at once is catastrophic. And here again, you have to have a clear understanding what's higher priority, which customers are higher priority. And it goes back to having a very detailed plan and a very clear playbook. You just follow the playbook step by step, and you have full understanding and control of the DR process. Securing of your delivery pipeline. The software supply chain and security in general is something that's become very high profile item on everyone's agenda. What does it really mean in our case? So there is a pipeline leading to your deployment, a code change that eventually reaches your production environment. That pipeline of all the way from Git to Kubernetes is, I would say, very, very susceptible to error and very susceptible to malicious actions. It means, or it implies, that you have to have the control over each and every one of the steps in this pipeline. If you rely on external tools, external providers, then you have to be very clear on how good do you trust them. All right, because they could be compromised without knowing. They could be a wonderful service provider, but other service providers have been compromised. So you should make sure that anything you rely on from an external source is still under your control. For example, just from our platform, for example, if I'm using a remote repository, which is a repository that allows you to fetch binaries from an external public, like from Docker Hub or from GCR into your local Artifactory, then you can still scan the binaries that were pulled by this remote repository, by your X-ray, and then you can validate that they're good to use, and you can continue pushing them into your pipeline. You don't have to always host them locally. You can use this remote methodology. And apply quality and security gates along all steps of the pipelines. That will give you higher trust of the users and of yourselves, of the pipeline itself, and will guarantee higher quality. Enforce rules and policies. Today, Kubernetes has multiple solutions towards enforcing rules and policies. So you can use admission controllers to enforce rules. For example, an admission controller that will not allow you to deploy a particular version that's been blacklisted for some reason, because security team found a suspected version and they haven't finished in evaluating it. So they've marked it as suspicious. You can use something like OPA gatekeeper, to enforce some policies. For example, we use it to enforce all container registries that are used for our deployments to be registries that we control. So we will never deploy a workload into our production clusters directly from a different service provider that's not in our Artifactories. So there's a little snippet at the bottom, like the allowed repository is releases JFrog IO. That's our registry. We have full control over it. We're the only ones deploying there. So it gives us the confidence that we're safe to use it. And of course, use role-based access control on any access to your Kubernetes clusters. There are various solutions and tools to audit this. And consider some runtime protection solutions. We have something baking in the oven for that. Hopefully, will be introduced by the end of the year. But a runtime protection solution, meaning something that actually is aware of what's running in your cluster, what's the risk, and what to do in a case. If I find a workload that has a critical vulnerability, can I remove it? Should I block it? Things like that. Workloads isolation. It's always good practice to isolate the namespaces. The workloads, we use namespace isolation with simple network policies. It helps us to block any lateral movement in case of a remote code execution. So I have the confidence that each of my namespaces is fully protected from a potential other namespace in case it's been compromised. You can take it one step further and run critical applications on isolated nodes, because if you have escaped the container scenarios, you can look it up what that means. You can actually access the underlying container engine that's running on your node, and then the namespace isolation will not be relevant anymore. So you can isolate critical services to dedicated node pools. If you go back to what I've mentioned earlier in this demonstration. Just a second, sorry. Secure your environment. Assume that your network is always under attack. Okay. Use auditing SIEM to detect any suspicious activities in your clusters or infrastructure. Have the runtime protection that I've mentioned with full visibility and control of the workloads. Have a strong incident response team. What happens if our auditing system suspects something and is alerting? So again, incident response with a clear playbook. It doesn't have to be a dedicated group. It could be part of a role of an existing group. with a very clear playbook, practice regular drills, just like disaster recovery. This is on the same sense of urgency. You can use bug bounties, sorry, to try and have external researchers try and compromise your system. It's always good to work with someone who doesn't know your system from the inside and can apply some black box methodologies and objective research, and use some pen testing tools. Continuous learning. I think this is probably a key lesson of itself. You continuously collect historical performance data in order to evaluate, deduct the action items, and apply them. And it has to be small steps. It has to be continuous. Things that you've done a year ago might not be relevant anymore. You might have drifting of performance of some applications metric. If you're aware of it, if you are proactively looking for it, it can help you dramatically in improving the stability of the system. Just a small example, a few years back, we've noticed that one of our services is very, very slowly leaking memory and CPU at a rate that it was about a 20% change within a week. So you could argue that it's insignificant, or you can argue that it's catastrophic, but no one saw it until we were actually looking for something completely different. And we saw this trend over a week, and we actually found a bug, a performance bug, in a very popular third-party tool that we're using. And we reported this, it was fixed, and indeed with the new version, it's fixed. So that helped us in improving our understanding and our performance of the system. We continuously evaluate the data to look for trends, to look for anomalies. And when we do it proactively, we find that we are much more comfortable in researching the results and applying the changes rather than reactively hitting a challenge from an alert that comes at real time. Remember, the humans are the weakest link. We have a saying that never send a human to do a robot's job. And in the world of ChatGPT and other automations, you should always go for automation. There is an exploding ecosystem of solutions. There isn't one right solution. Everyone should find their best match, whatever fits their processes and definitions. It seems that GitOps has taken over the world, and everyone's going there. So evaluate and see if it works for you. GitOps seems to be a very friendly way of introducing changes all the way to production by even developers. Git introduces kind of a very well-known contract and interface to managing configuration changes. We've been using it for many years. We did it before it was known as GitOps. So we don't call it GitOps, but that's in practice what we do. We have multiple repositories with different sources of different types of configurations, and it works for us. Always keep a very clear environment separation of your dev from staging from production. That seems trivial, but it's not always that. Although you'd like the environments to be very similar to each other as much as possible, they should still be very, very well separated from each other. And also make sure that no one accidentally deploys a staging change or a dev change to production. So take that into consideration. The future. AI-powered solutions are probably the future. And I think that we're at the beginning of seeing how AI can really take a lot of operational complexity off our backs, and we can offload the day-to-day tasks of managing our environments, managing our deployments, managing our basic troubleshooting. But I don't see anywhere where human judgment will be replaceable. So always take it with a grain of salt. Be mindful and careful The reality is that AI engines today are fed by public knowledge. Public knowledge today is full of BS, to be honest. If you've looked up media sites, social networks, and very old blog posts, you see things that are either wrong or outdated or irrelevant. And your AI engines are still collecting this, and they need a while to understand which is right and which isn't. So I've many times seen answers being fed back to me that were simply not working because they were written on a very old API version. So I had to understand, why isn't it working? Because it was using a feature from an API from 5 years ago rather than a new one. Always use common sense and plan to fail. The key takeaways I want you to take from this webinar before we complete: control your pipelines, okay? Fully automated and controlled software development lifecycle. And it has to be under your control, not anyone else's control. Even if you're using a managed service, you need to make sure that it's under your control and you know what's going on in there. Secure your pipeline, zero trust, and apply security gates. All right, every entry gate into the next stage should not trust the previous one. So there are various ways to take that and apply that, but it's not a very simple principle to apply, because you'd say, yeah, I built it once, leave me alone, I would just want to take it to production. But the road to production has many hops. Plan to scale and plan to fail. All right, assuming everyone here is an optimist, you see your company growing twice as big within a year or two, then you need to plan to scale. Be ready today, not within 2 years. And being where we're all skeptics, you will eventually fail. Something will eventually fail, not you. But you will find the solution for that failure before it happens. So plan for it. That's the end. I thank you all very much for listening in. I'm going to go to the Q&A and try and answer some of the questions. Here we go. Okay, so I'm looking at the questions. What is the observability stack you use? So we have a collection of a few solutions. The trivial one, we're actually collecting with Prometheus. We're using to collect system and application metrics. Our applications expose their metrics on the, just a second. Our applications expose an open metrics API metric, so we collect it and we present it as well. We have Prometheus collecting it, we have Grafana presenting it, and we have some alerting system built on top of that. We're also collecting logs into an external log collector, and over there we're using FileBeat and Logstash to collect logs and send them to an external service provider. Over there we have all the dashboards, we have all of the alerts based on patterns that we find in the log. I hope this it provides you with the answer. Next questions, thoughts about your overcommitting. How does it affect auto, horizontal, vertical scaling? So this is a really hard question to answer, because it really is a per service behavior. For those of you who don't understand or are not very much familiar with the overcommitment term, basically it says that when I allocate resources to a container, let's say my Artifactory container, I can tell I need a required 4 gigabytes of memory, but I'm okay with it growing up to 8 gigabytes. All right. So if the application grows, it goes into what I call the danger zone of beyond the request. But if I know that it comes down back into the safe zone, then I'm okay with that. So I'll allow it to grow. The thing is that if you have multiple pods in the same node, all growing together beyond into their danger zone, then you hit a problem of resource starvation, where you don't have enough resources to meet the required at real time on-demand resources. So some of the service, we've actually applied what we call a guaranteed quality of service, where the request is equal to the limit. That gives me a guaranteed resource set for my service, regardless of what's happening beyond that service in the same node or pod. If you remember earlier, I said it's always recommended to scale horizontally, add more replicas of the same service running in your cluster and spread the load. But in some cases, we have no other choice but to grow vertically because of the nature of the service. So it goes back to combining horizontal scaling, vertical scale with a request that is lower than the limit, but we know that it will only be temporary. And together with pod priority, we know that when it comes to the money time and the Kubernetes needs to reschedule one of the pods, it will take the lowest priority pod on my node, which is not that bad. So I'm okay with that. So I hope I'm answering you here, Daniel, because it really is different for every one of us. And it requires to have a very good understanding of how applications work, and also test it, continually test it and challenge it and press it to its limits. What happens if I have multiple services which are on the highest priority and I push them all to their limits? What happens? So that should be your worst case scenario. Any specifics for upgrading, migrating clusters, mainly control plane? Any gotchas? That's another good question. We rely on the service provider's capability of operating clusters. Usually what they ask you is upgrade the control plane first. They do it seamlessly behind the scene. And when that's ready, then you're ready to apply the cluster or your worker nodes upgrade. What happens at this case is that we found that instead of upgrading the nodes in place, spinning up a new node pool with a new version and gradually migrating to it is safer, is more stable, and is under better control for us. So you can look at it that we've spun up a new node pool and we are gradually retiring the old node pool. And when that's done, we delete that node pool. So that is gradually rolling. It's a process that is slow. We intentionally like it to be slow because new nodes coming up and rescheduling of pods is an intensive process of its own. And we'd like and prefer it to be under our control, and better safe than sorry in this case. It allows us, by the way, to be fully highly available and keep customers' availability without any impact. And we do it, by the way, on a quarterly basis, sometimes more if there's a security fix that needs to be rolled out. And it's a fairly straightforward process. Our teams have developed the automation around it. Okay, so this was answered. Okay, so I see no more questions in the Q&A. I hope I gave you each one or two items to take back with you. I thank you for joining me on this webinar, and I'm hopeful that your Kubernetes journey is simple and very interesting on your daily basis and doesn't keep you awake too much at night. So thank you very much. Enjoy the weekend coming and see you on the other side.